So, we're doing this work sample on probability, which you guys have seen before, but we're going to kind of define it. So, probability is just the chance something will occur. Oh, like if anybody ever says, what's the chance you're going to pass this class? Like, 50-50, that's a probability.
No, 80.
So usually probabilities, we write them as a fraction, a percent, or a decimal between 0 and 1. So like a lot of times you'll see the percent of winning is like 25% or something like that. We're not going to do percents, we're going to do decimals to keep it easy. So it'll be easier this way, and that'll be fine. So even though percents look nicer, decimals are going to be fine. So in order to find probability, we're going to find the probability of rolling the number 2 on a regular dice. I don't know. Number cube is what the book likes to use.
Would it be 1 out of 6?
So let's go over it. Yeah. So to determine the probability, take what you're looking for and divide it by the total possible.
Hold on.
So I want the.
I'm not gonna leave. I just hear something. It's weird.
We want the number 2, right? How many times does the number 2 show up on a regular dice? If you're rolling a regular dice. I'm not trying to trick you.
Who's standing up there? Really? It's even
She is. So it's fine.
So,
Grab a paper. So how many times does the number 2 show up on a regular dice? Once, right?
Yeah.
And how many possible outcomes are there?
6.
6, right? If you're going 1 through 6 on a regular dice.
I said 1
Yeah,
out of
I
6.
know you did, but I wanted to walk through it. So in order to find the probability of rolling the number 2, we take the number of times that can happen, which is once,
Divided by the number of possible.
divide it by the number total, the total numbers, which is 6. I'm going to grab decimals real quick. Grab each of them.
Oh, dang, I don't even have a computer. We just came in here and sat down on jumps.
Dude.
Wow.
Oh, flip.
Alright, there we go. So, we are going to find the probability. We're just going to go 1 divided by 6 in Desmos. Come on, Tim. I believe in you. And so we get a big decimal when we plug this in, which is fine. When we do this, I want at least 3 decimals.
Wait, whoa, what are we talking about?
So I
Oh,
did 1 divided by 6, and I get 0.1, and then a whole bunch of 6s, and then they'll round the last one up to 7. When you do this, I want at least 3 decimals. So don't give me 1 or 2, give me 3.
So the number point and 3 decimals right, correct?
Yeah. So it should almost always be 0 point and then something, which we'll actually talk about in a
So
little
we
bit.
don't have to put the 0, we just put point.
You could just
1,
put
2,
point.
3.
So 0.16, and let's actually round it up to 0.167. You have a 0.167 chance of getting the number 2 when you roll a regular die. If we were going to do percentages, because I tend to work better in those,
16%.
so it'd be about 16%. Yeah, right, 16%. But we're going to leave it as decimals. This is perfectly fine to leave it like this. And it's less work to leave it like this, so that's what we're going to do. Okay, so we're just going to practice finding some probabilities.
Nope, hate us.
All right, these are really small. These look a little nicer. Okay, so if we're going to keep rolling a regular dice, let's find the probability of rolling a prime number. Anybody remember what a prime number is off the top of their head?
3,
2,
6, 9, 7.
2, 4, 6.
Some of those were.
Oh, it's just 1, 3.
Remember, a prime is a number you can't divide without decimals. So 1, 2, 3, 4 you can divide, right? 7's another one, yeah. 5's another one.
1, 2, 3.
And
Is it 9, 1?
9 you can divide by 3.
Oh.
But we're on a regular dice, right? Do I need to go past 6 if I have a regular dice?
No.
No. So how many times do primes show up on a regular dice?
4 times.
4 times, right?
Oh my god.
There are 6 total. So to find this probability, it's just 4 out of 6, which we're going to plug into Desmos.
Sir, it won't give me.
We're going to go 4 divided by, oh, come on. There we go. 4 divided by 6. And this is just 0.667. Remember, 3 decimals. And I'm going to round this 6 up to a 7, because I look right next to
Did
it.
you round all up to a 7?
No, because we're going to end at the third one, right? So only the third one changes.
Wow.
So we get the probability is 0.667. Or if this was
66%.
percentages, it'd be about 66%. Yep. Okay, we're going to do the next one. Find the probability of rolling a multiple of 4. Multiple is where you take this number and it's like you count by it. So 4, 8, 12, 16, those are multiples. So how many multiples of 4 show up on a regular die?
2.
What are they?
2 and 4.
Not careful though. Just 4.
1 and, just 4?
Yeah, it's like you're counting by 4s. It's like we're going 4, 8, 12,
But
16.
I thought it was dice.
Yep.
What?
So we stop at 4, right? Because there's only 6 total. So there's only 1 out of 6, which we did earlier.
10% chance.
Right? And we got 0.167.
Oh, yeah.
We just did this one on the last
I
slide.
just thought 1 out of 6. So.
Yep, 1 out of 6. So that's all it is. So remember, multiple means you just count. Count by. And we're going to count by 4s. This one. That's all multiple is. Mm-hmm. But we only need to stop after 6 because there's only 6 sides on a die. Alright, let me make this a little bit bigger. Hang on, so it's a little easier to see. Alright, how about let's find the probability of rolling factors of 20.
1.
Factors are, yep, there's 1. Factors are what can you divide 20 by and not get a decimal.
4.
So 1,
2.
4 is the other one, 2 is
5.
another one, 5. What about, let's see,
That's it.
yeah, 3 doesn't work, 6 doesn't work, right?
Yeah.
Alright, so there are 4 total
Out of 6.
out of 6,
It's 0.667.
which is, we already did, right, 0.667. When you talk about like dice, they tend to be the same numbers because there's only 6 different options.
Yeah.
Alright, let's have you guys do number 5 on your own. I
Well,
want you to find the probability of rolling a multiple of 5.
What is that? 1?
Remember, multiple is where you count by 5s.
So just 5?
So, 5.
1.
Oh,
Last one each side?
Kind of.
I don't remember the answer.
Did you not write it down?
What's it saying?
I'm watching the get there.
No, not yet. No.
It's
What are you talking about? Everyone watch your phone at the same time? I'm kidding, I don't even know.
studying, huh?
Alright,
I'm
so how many multiples of 5 show up on a regular dice?
1.
Just kidding.
Just ones, right? Out of 6 total, which we've done this one a couple times, 0.167.
Big, you still
Our
lying.
probability. Pretty good? Okay. Let's look at a couple more, and then that's actually it for the first one. Like I said before, we're going to do the math for a couple days, and we're going to take it nice and slow and make sure you get this down. So let's look at these next ones. What's the probability of rolling a die and getting the number 7?
0.
0, right? It shows up 0 times out of 6 total, which is just 0.
Wow.
If your probability is 0, that means it will never happen.
Never say never.
No, this one's never going to happen.
Always say never. Always say never.
So that means it will never happen. Alright, how about, let's find the probability of rolling a die and getting a number less than 10.
Oh, what?
How many numbers?
times.
There's 6 total numbers less than 10, right?
Six.
There are
One.
6 total,
1.
which equals 1. If you get the number 1, that means it will always happen.
So that's like what, 100%?
100%. So 0 is 0%, never happen. 1 is 100%, it will always happen. Alright, and let's do one last one. So this one's a little different. We're going to find, or a number is chosen at random from 1 to 50. Find the probability of selecting multiples of 6.
I was like, he reached Nirvana.
Oh, no.
So this one is a little different because how many, what am I going to have in this divide by part on the bottom?
50.
50. Because there are 50 total, right? So this isn't just a regular dice. there's more than that. So we're going to find the probability of selecting multiples of 6. Remember, multiples means count by.
So 6,
6,
12,
24,
12,
30,
18,
or 24,
24,
36,
30,
or 30,
30,
36.
36, 42.
Oh, see.
Wow.
Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8.
No, there's 8.
Yep, 8 out of 50, right? So plug it into Desmos because we haven't done that one yet. 8 on my 50.
Wow.
And we get 0.16.
That's
There's
what
only
we're
2
working
decimals. If there's less than if there is less than
3.
3 decimals, just write everything you have.
So,
So we're gonna go 0.16. So the probability is 0.16. And that's it. That's all we need to do.
No.
Okay. We're actually done with this first part. We're just doing a nice, easy intro to probabilities. So what I want you to do is, I want you to do this exit ticket.
nope, can't do it.
So a number is chosen at random from 1 to 50. Find the probability of selecting a prime number.
So
And I'll put a prime number thing on the board here so you can see it.
1, it's
25.
2, it's 3, it's 5.
So between out of 1 and 50, and this isn't on Socrative. You're gonna do it on your own, and then we're gonna check it together.
I don't want to do
So-
it so many times. I don't want to count that many. I don't want to write it all the way out.
You don't have to. I'm gonna put the thing on the board for you. Prime number thing. I used to have a poster, but I had to take it down for smarter balance. So hang on.
Put it back.
Okay.
Alright, cool. Wait, what? You ruined it.
Dang it. Give me mic.
What? I got it.
Soiled it.
Go
I wanted it to be bigger.
You can't.
Just copy it and put it on something else. Zoom in.
Copy image.
No,
Sorry.
copy image.
Copy, don't say.
Copy
Can I
image.
Go to Google Docs
Go
and do it.
key.
Get out of here. Can I not just look at the big one? Worthless.
That's what 1,
Zoom in. Ah, I broke it.
1, 2, 3, 4, 5. So 5. 1, 2, 3, 4, 5, 6. Whoa,
Oh, that's
whoa.
a prime number.
Wait, 1
No,
is not
so-
a prime number? What?
Hang on. Oh,
Okay,
where'd
just
it
leave it
go?
alone.
Wait,
Um,
1 is not a prime number.
You know, that's a good question. One might not be prime, actually.
Liar.
Because one can go.
You lied.
I don't know. I have to double check. I feel like it is, though.
9, 10, 11, 12, 13,
Mm.
14, 15, 16, 17, 20, 21, 22, 23, 24, 25. Hey guys, it's 25.
But be careful. What is it out of?
Oh, out of 50. So
Out of
take
50.
away like, what did I say?
You said 25, take away half.
25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15. It's 15.
Okay. So figure it out. What's the probability?
Yeah.
15 out of 50. So divide that.
You know what? I'm not gonna write all that down. I'm just gonna key off Lucas.
0.3. So does it 30% chance?
Yes.
Mm-hmm.
Sorry.
Don't be sorry. You got it.
All right. So there were.
That doesn't work.
So there were 15 numbers total, right? When you do these, you don't have to list them all. You don't have to go like 2, 3, 5. You don't have to do that. You can just give me the answer.
That's what I did.
So there were 15. That's fine. It's not like you're wrong. It's just you don't have to write that much.
I went all the way to 5 and I was like, I'm just gonna count them.
Yep, that's fine. That's fine. So there are 15 total out of, or there are 15 there out of 50 total, which is 0.3. Which, if you were doing percentages, would be 30%. But you don't have to be percent. You can just say 0.3. It'll be done.
That watch 1930.
So, I have a practice worksheet for you guys. You have to do. There's only 10 of them, so you just have to do the 10. Once you're done, turn it in. Remember, we're not doing proficiency quizzes over these because it's going to be for a work sample. So you don't have to worry about that. But I do want you to get this homework done because I want the math to be easy by the time we get to the actual work sample.
So.
And hang on to this
second,
paper
I'll
like
have to
normal.
do this?
That way you can use it for notes and stuff.
I'm transferring.